Hello and welcome back. In our last lecture, we built our first Lambda function and we came across few terms like service, functions, events, provider, and we tested our function locally. In this lecture, we are going to understand these different components that build our serverless YAML file, our service, in a little bit more detail. So services are just functions, events, resources, and outputs in serverless YAML file. We haven't yet worked on resources and outputs yet. In the upcoming lectures, we will see how we can create different resources. Once we deploy our code to AWS, we will get output values. Outputs are nothing but references to all the resources that we create, and these references can be utilized by other services to connect to those resources. Now you can think of a service as a project. So just like we have different teams working on different modules in a project, we can have different services created for each of those modules so that we can segregate the business logic across different teams and they each can focus on their own code piece. For example, if we have a project where we have users and users are commenting on certain posts, we can have three different services, for one for user, another for post, and another one for comments, and each of these services will have its own serverless YAML file with their own set of resources and API endpoints. For smaller projects, we can have just two services, for example, one for front-end code, another one for back-end APIs. So front-end service will have CloudFront S3 bucket where we can deploy our front end, and backend will have the API gateway and all the database related resources. So we'll see all these in action in upcoming lectures. We also see how we can create a service using a simple create command that serverless provides. We can use one of the templates and define the path where we want to create a service, and serverless will initiate a serverless YAML file. Now all the functions that we are going to create, because we are using AWS as our provider, these functions are going to be all Lambda functions. Now in our first Lambda function example, we saw how we had certain properties under provider section like name and runtime, and these properties get inherited by all the functions that we define under functions property. So for example, here you can see we have some more properties defined under provider like timeout, memory size, and we have also the same properties defined under one of the function here, hello, with different values. Now all the functions that we create will inherit the properties defined under the provider by default. But if you want to override one or more of these properties and define a different value for one of the function, we can always override them by defining them locally for each function. Here I have another example with a lot more properties, just to give an idea what all is possible using provider and functions. Here we have some more properties defined under provider, for example architecture. Now by default, Lambda functions are run by 64-bit x86 architecture CPUs in AWS, but you can always switch the architecture to ARM64 architecture, which may result in a better pricing. It can be cheaper and have better performance. Before switching to ARM64 architecture, just make sure that your code is not dependent on the architecture CPU type. For that, I have added a link to AWS documentation. So do refer to this link called Foundation Architecture Consideration before making the switch to ARM64 architecture. So there is a set of dependency check that we need to do before you can do that. Now there are other properties that you can add, like if you want to add your Lambda function in a certain VPC under a security group under a subnet, you can do that. You can define the VPC in provider to reflect across the functions that you define by default. or you can define the VPC for a particular function that you want to exclude or include. Here I have excluded the function that I don't want to be in the default VPC that we have defined in provider. In the same way, you can define multiple environment variables in the provider property, and then you can also define the environment variable under individual functions. You can override the environment variables under specific functions with a new value, but if no environment variables are defined under a function, they will always have access to the environment variables defined under provider section. Similarly, you can define tags. You can disable the versioning of functions. By default, AWS will keep a history of all the versions that you are deploying. So every time you deploy any update to your stack, it will create a version for that. So if you do not want to keep that version, as each version will occupy some space. There are other properties like layers. You can disable the logs. You can have log retention days defined here so that you don't keep logs that are too old. So these are just few examples of all the properties that you can set for provider and functions. We are going to use most of these in our project in upcoming lectures. Now let's move on to events. So simply put, events are the things that trigger your functions. Now when we are talking about AWS as our provider, there are various different events that can trigger your function, like API gateway, S3 buckets, SNS, SQS, event bridge, your DynamoDB, etc. I've pasted here some screenshots on how you can add an event to trigger functions. For example, the first one shows how you can have a time triggered function or a cron job function. Here we can see that the crawl function triggers every 2 hours. In the next snapshot, we have a API gateway triggered function. It's a post call triggered function. And then we have a S3 triggered function. So these are just some of the examples. If you go to Serverless AWS Lambda events documentation page, you'll see that there are a lot more different services that can trigger an event to run a function. Like Kinesis, we have IoT based events, then Alexa scale, your RabbitMQ, Apache MQ. Even if you are running a Lambda function which is creating some CloudWatch logs, even those logs that are being created by one Lambda function can be used to capture an event and then trigger another function. So here's a simple diagram explaining how you can use different events to trigger different Lambda functions, and then in turn those Lambda functions can act on the triggered event, and the events itself comes with some data. Like for example, if an event is getting triggered through an API gateway, then you might get some path parameters or query parameters or some post body that Lambda function will receive as event data. It can act on that data and then further process the data and probably make a entry in SQLDB or a DynamoDB, or trigger another Lambda function, or make some entry in S3 bucket. So this diagram just shows like how you can have different events triggered by end users, or you can also have events triggered by DynamoDB based on some update being done to one of the items in DynamoDB, for example, using another Lambda function. So by using all these services emitting different events and triggering different functions, we can, as a developer, focus on just your business logic, and Serverless Framework will take care of integrating all these different components in your project and kind of paves a path to create different microservices. So you can have all these services in sequence, or you can have something like a fan out architecture where one event triggers multiple different functions, which in turn fulfills one of the underlying business logic. So that's all for this lecture, and I will see you in the next one.